Hello guys, in this video I'm going to show you how to solve a pretty common interview questions, which is implement a queue using two stacks. Do not create an array inside the queue class. In the previous videos we've implemented a queue with two methods, with method add and remove, but internally we use a stack, we use array, right? But in this problem, it's not allowed to use create an array, but the requirement is to use two stacks. The queues must support common operations, which is add, remove, and pick. Reminder on what each method does look like. Okay, so let us see an example to understand how we can solve it. For the order deleted, as requirement we have two stacks, stack 1 and stack 2. The order the orders that numbers are pushed into add to the queue is 1, 2, 3, 4, 5. Let's say let's say we want to add, now let's change it a little bit, add 1, add 2, add 3, pop, remove, will remove. For queues, remove method will remove the first, because queues is first in first out, so remove, we will remove the first one, the head of the queue, which is 1, right? We expect the remove function will return 1 and also remove it from the internal data structure. And we push again, we add 4, we add 5, here the order of operations. So how we solve it? Let's because we have two stacks, let's try to add let's try to work on the stack 1 first. We add 1, right? Here the we add 1, we add 2, we add 3, right? So here is the head of stack, the top of stack. 3, we can only take the top elements of stack out first, right? But the remove operation, for remove operations, we need to take out 1, right? Because from the queue perspective, 1 is the first thing we add to the queue, right? Here is the internal data structure only, so 1 is the first thing that is pushed to the add to the queue, and should be the first one is pop out. So it means we need to somehow take this one, take the one out of our data structure. As you can see, an intuitive solution here is because we have two stacks. We're only using stack 1, we have stack 2 also. In order to get the one which is at the bottom of the stack now, it's simply by put everything from stack 1 to stack 2, so that we have a reverse order of what is in S1 now. So 1 will be on the top of stack 2. Let's do it one by one. For 3, we pop out from stack 1, we add to stack 2, 2 pop out from stack 1, add, push to stack 2, and the last one, 1, go to top of stack 2, right? So now we can remove 1 from stack 2, right? Let's add 1 remove down here. Right, we can remove here, right, we remove 1 from stack 2, add 4 and 5, right. You may realize that the mechanism behind how we store data, which is one stack is to push data in, and one stack is for popping data out. Right? We had 4, push 4, and push 5. We're here, and now we go to remove, because 2 the result we want here is 2, right? Because 2 is the second item that is add a queue, so it should be because 1 already pop out from the queue, so now it's time for 2 to be removed out. So as you can see, 2 is already on top of the stack 2. Stack 2 is simply for removing from the queue. Okay. So we remove 2. So as you can see, the logic here is the logic behind is for S1 is for adding to the queue, and S2 is for removing from the queue. Actually, there's 2 cases that there are 2 cases that we need to consider, which is first thing is here when we first remove, the S2 was empty at the time, so we need to, if S2 is empty, we simply push everything from S1 to S2 before removing from S2, popping out, right? Popping out. If S2 is not empty, we simply pop out from S2. Let's implement it. We have two stacks. This does S1 equals to new stack. This does S2 equals to new stack. The first operation here is Q. We have add and remove and pick. Add and remove and pick. Add, we will take in the value. We use stack 1 for pushing to the queue. Push file to remove. There are two cases. So if this dot S2 I want to check it empty if it's the pick. If the pick is not empty, if there is a pick element, which means the stack is not empty, we just simply return S2 dot pop out from S2. But if we go down here, it means there's no pick element in S2, so it's S2 is empty. We want to reverse, put everything from S1 push to S2. So as long as this S1 still has a pick, we want to this dot S1 push we want to push the S2, push what? Push the thing come out from S2 from S1, right? Down here, return this dot S1 S1 dot pop. We remove from S2, right? S2 pop. The same ideas is applied for pick, I think. If nothing here, simply return pick. We not pop S2, but we return pick, right? But if we come down here, it means there's nothing in stack 2. Take everything from S1 and push to S2, and then we return this S2 dot pick. There's only one thing different here between these two is for remove we pop it from the stack, but for pick method we only get the top element of the stack. Okay. So let's try it. Let's test it. Just Q from. Hopefully it work. Hopefully it will awesome. But let's do a little bit of I don't know how to can be optimized a little bit here, because there's a lot of same logic between these two let's say this party same. So we can abstract out to another method. For example, take from S1 to S2, so everything down here. Select it, and this tag form, there's nothing too fancy here. We just try to avoid repetition by moving the same logic into a function. Awesome. Thank you for watching. See you in the next video.